Hello everyone and welcome to this presentation, Industrial OT Cybersecurity. My name is Mohammed Mahjoub and I am the CISO for Veolia Middle East. Veolia Middle East specializes in wastewater treatment, water desalination, and providing mixed utilities such as district cooling. Today I'll be sharing with you some best practices and some recent projects we have conducted in VME when it comes to industrial and OT cybersecurity. Cybersecurity attacks keep on coming and there is no end in sight to stop these attacks. We live in a critical geographical region here that has some political turmoil taking place. So attacks will never stop, but what we know is that we need to take precautions on protecting our critical infrastructures. Let us first start by creating a differentiation line between the IT and OT. IT is non-real time, so it can tolerate some delay. Meanwhile, OT cannot do that, especially if you're running critical infrastructure. When it comes to network, IT needs high throughput, delay, and jitter are acceptable, and you mainly have networks with localized capabilities. But when it comes to OT, the throughput is somehow modest, but delay and jitter are not acceptable, else it will affect negatively your operations. As for the communication media, we have various types used. In the OT, availability and rebooting is generally acceptable. However, you cannot do that when it comes to industrial networks. In IT, we mainly focus on protecting the data and the assets. Meanwhile, in OT, we mainly focus on the human life and human safety. Fault tolerance in IT is acceptable. Meanwhile, fault tolerance is less acceptable in the OT. The risks in IT is the delay of operations. This is the worst case scenario that can happen, but the worst case scenario that can happen in the OT environment is human loss and human life loss, which is really disastrous. Systems resources are enough in the IT. Meanwhile, system resources are limited due to the, so to speak, the outdated technology or the old technology mainly employed in the plants. In IT, we use standard protocols. Meanwhile, in OT, you will see a myriad of mixed protocols, not just a standard protocol. Change management is pretty straightforward in IT, but in OT it's quite challenging. As we've said earlier, you cannot, or it's difficult to reboot a server, for example. The lifetime span or the lifespan of equipment in IT is 3 to 5 years. Meanwhile, in OT you'll find really legacy classic hardware that goes back to 50 or maybe 20 years. Physical security in IT is like you mainly have a server room with some access control. It's easy to access. Meanwhile, in OT is usually isolated. Plants are usually isolated, but nowadays convergence is the name of the game. Plants are being connected to the business networks. So the general challenges we're facing today in OT networks is the lack of visibility of our assets. You know that the assets are there in the ERP system, the financial system, maybe they're on an Excel sheet, but actually it is challenging to get them with a click of a button, to get the updated list of assets that you currently have in the plant with a click of a button. So this is a prerequisite to any other initiative. When it comes to cybersecurity, you need to know, you need to realize the assets that you have. The other challenge is not being able to rapidly detect cyber threats. So if you don't have an eye inside the network, of course you will not be able to detect what's going on there. And the third challenge is not to be able to significantly reduce troubleshooting and forensic efforts because you don't have the required tools to do so. So, in addition to these general concerns, we have some specific OT concerns. So, it's uncommon in the OT world to have staff dedicated to cybersecurity, as we have in the enterprise network, for example. Mainly, this trend is being some more and more popular, but previously that wasn't the case. We don't have two separate environments, the test environment and the production environment. This doesn't apply mainly in the IT world, the OT world. Assumptions associated with the security design are not the same. We have different concepts when it comes to building up a plant from scratch. I'll be sharing more concepts, especially when it comes to Purdue model, throughout the presentation. Legacy systems exceedingly difficult to patch or upgrade. So it is somehow impossible to upgrade or patch a system in the OT network without affecting the operations or without causing a downtime. Another concern is the convergence or the trend of converging IT networks and OT networks. OT networks are not isolated anymore. They will have they will have any kind of connectivity, whether it's a VPN for remote access, whether it's a IoT device just to push data to the cloud, and we're seeing this trend more and more. So no, the plants will not be isolated anymore. They have to connect with the external world, and this is the main security concern. On top of that, we have the classic vulnerabilities when it comes to vulnerable hardware, software, vulnerable stack. For example, this triple 20 vulnerable TCP/IP stack. Many hardware have implemented this track stack, they call it, for communication, and it's vulnerable. And now, with the convergence of networks and the connectivity to the world, these vulnerabilities will be more and more exploited. On top of the traditional threats that we face in the enterprise network, such as USBs with malwares and data leakage. On top of that, depending on the geographical location that you operate from, you might have nation-state threat actors, espionage, etc. So as you see, it's quite a complex spectrum of threats. In OT, we have mainly two types of attacks. We have attacks that can cause denial, loss, and manipulation of view, so the operator will not be able to view the control screen or the dashboard. He will be denied to view. He will not have access to the view, and maybe the attackers will manipulate some figures, some set points in that view. So this is the first type of attack. The second type of attack is the control. So the attackers will deny the operators the control of their plant. The operator will not be able to see and control. So the operator will lose control, will lose the privileges to manipulate and to control their plant. So these are mainly two main topics when it comes to attacks in the OT world. It has to do with the view and the control of the plant. Now, since we're operating from the GCC, it's good to shed the light on the regulatory spectrum here. I can say that it's becoming more and more mature. On top of the worldwide regulation standards when it comes to ISO 27001 or ISA 62443 or even NIST, we have some local regulatory governance bodies when operating from Saudi Arabia, UAE, Oman, etc. And the spectrum is becoming more and more mature, and I expect that we will have a common maybe standard in the near future when it comes to securing the OT operations. We have been doing some research earlier in VME or VOL in Middle East, and we were able to spot some products that will give you access to your OT network. It will give you a network visibility. It will give you the ability to detect threats, and it will give you operational insights from all your plants. So in VME, we know that to mitigate all these threats that we've mentioned earlier, you need to have a well-defined defense in-depth strategy. We're working on all these aspects when it comes to policies, procedures, physical security, edge security, etc. But the solution that we're going to discuss today has mainly to do with securing operations at the edge, the OT network, and the host level. So what will this system do? So this system will give you enhanced network and asset visibility. It will give you the list of OT assets you have in terms of PLCs, RTUs, HMIs, SCADA servers, etc. It will give you the details of these lists. On top of that, it will give you a visualization of the topologies of the network you have, of the protocols that you're running in your plant. So this is the first advantage. The second advantage is the enhanced operations. Now you know the list of assets that you have. You can customize some set points that you need to monitor in your plant, and you might get alarmed if the processes variables have changed, because this is one of the techniques of the attacker. They will usually change some variables and some set variables. So this system can help you monitor these critical process variables and will alarm you in case there is a change or there is an unexpected change. It will as well help you in analyzing the traffic, the bandwidth between your nodes, so that it might trigger some alarm if there is an unexpected like traffic taking place between two entities. You'll be alerted in case of any discrepancies when it comes to network communication and protocols in your plants. The third added value is the enhanced security. So you'll be able to come up with your own use cases and you'll be able to implement those use cases in the system. For example, you might want to be alerted when there is a new workstation that's connected to the network. You might be alerted when there is a new kind of protocol that's operating on your network, such as peer-to-peer, for example. So the sky is the limit here. Many systems offer the capability of incorporating your own use cases in their system. And last but not least is the usability, because as you know, the main advantage offered by such systems is the ability to connect different sites and the ability to integrate all these sites into one dashboard. So of course you need to define various users with multiple privileges. You'll be able to take snapshots from each plant, compare it with, for example, this is the snapshot of the second plant. You might be able to take some baselines for the traffic and build the history based on that. I mean, flexibility here is important when it comes to utilizing such systems. So what's the general setup of such systems? These systems are mainly there to talk to the hardware in the plant, the PLCs, RTUs, servers, etc. So it needs to have access to the main industrial switch. It will be connected to the main industrial switch on the span port, passive mode, of course, just to read the traffic. So you'll connect it here between level 1 and 2 of the Purdue model, and the device, it can be a hardware device or a virtual server, will push all the metadata to a centralized management console which is there on the cloud. Of course, it will communicate securely. You don't have to open all the traffic. You need to specify and open some ports between your OT network and the IT network, and eventually to the internet. So how does it work? Actually, it starts by identifying the assets, know what you have. Then it will assess the level of risks and vulnerabilities on those assets. After that, it will detect any cyber threat. Based on that, you will be able to get notifications, alerts, emails, etc. You'll be capable on acting and remedying or fixing the issues here. And when it comes to scalability, such systems are able to connect thousands of plants. So imagine the added value and advantage you'll be able to have when connecting all your plants into one dashboard. It's really amazing. So just a generic peek on the system. The system will be able to visualize your network here on the left, and you'll be able to drill down more on each of the nodes, and the node will be expanded here on the right side. Uh, Another added advantage here is the color coding thing. So, for example, this is a terminal, and these are master servers, and the rest are slave servers. It's up to you to customize the servers and the nodes you want to see, but really it's a nice view of live and updated view of the network in the plant. You will be able as well to visualize the traffic and the utilization or the bandwidth currently in your plant. Red links here show that the utilization is really high, medium link and low link show that the utilization is less. So in case there is for example, a malware that's communicating with the command center, you'll be able to easily spot it here. Malicious traffic will be able to be highlighted in this initial view. The system will be able to list all the vulnerabilities in all the hardware that you have in the plant. It will score them based on CWE and the CVE. You'll be able to drill down on each of these risks or threats, and you'll be able to see the recommendations and more details on that threat. The system is able as well to group the vulnerabilities based on a server, on a node, on a PLC, etc. So you'll be able to isolate or identify the components that are more vulnerable than others. Another added value here is the traffic analysis. So as you know, in the plants we have quite few protocols. For example, you have Modbus here, maybe you have Ethernet IP, Profibus, etc. So this system will be able to visualize the traffic and will give you a pie chart on the amount of traffic and the analysis of the types of traffic happening in your plant. So again, if there's something fishy, different type of protocol traffic taking place, you'll be able to see it here in this visualization. Another added value is that you'll be able to see the most vulnerable hardware by vendor that you have. It's really a good feature that it will isolate it will categorize the hardware that you have in the plant per vendor, and will give you the listing per the criticality and the vulnerability of the current components that are related to a specific vendor. So here, for example, we have SE have in the plants that have the most vulnerable components, and then AB, etc. It's really quite interesting view to have the vulnerabilities segregated by a vendor. As mentioned earlier, we have a process value change alert, so you can as well configure that, and if the process has changed to an unexpected value outside the window you have defined, you'll be alerted on the spot, and you'll be able to take the right action. So This system is really cool in terms of connecting all the plants. Uh, as I said, it has the ability to connect thousands of plants with just one dashboard available on the cloud. It can be AWS, GCP, or Azure. You'll be able to see what's happening inside the networks, inside your plants across the world. Uh, so the benefits of implementing such a system, especially here in the MENA, is that we will adhere to their upcoming uh, regulatory bodies, regulatory standards. This is coming on the way, so it's better to be prepared from now. The other advantage is that operations team will be able to have full visibility. So it's not only good for cybersecurity teams. No, operations team will be able to see the assets that they have. They'll be able to pull some data related to the hardware that will help them maybe in predictive maintenance. So it's really a handy tool when it comes to the operations team as well, not just the cybersecurity team. Of course, for the cybersecurity team, you'll be able to monitor your OT environment deeply, and you'll be able to take preventive measures, remove suspicious activities, detect threats, etc. So since you have this view, the visibility, you'll be able to fully control and monitor what's happening in your operational networks. And last but not least, when you have convergence between IT and OT taking place, it's really important to scale up the level of security you have in your OT. Uh, Such systems usually integrate with SIM solutions because at the end of the day, it's good to push this data to a SIM solution if you have a SIM solution. So such systems will interface seamlessly with SIM solutions. They will interface as well with ITSM solutions, ticketing solutions to create the incidents and problems, etc. And of course, they need to talk freely with famous OT equipment. So make sure to identify the assets that you have, the vendors in your plans before adopting any solution. And I guess that's all from my side. Thank you for joining this presentation. If you have any question, please feel free to reach me on chat. Again, thank you so much.